Hello, everybody. My name's Dave Freedman, and I'm sure most of you know me by now. I'm here with my colleagues, who I'll introduce in a minute, and I'm here to talk to you about something that we call internally Project Golf, and it's about using EVPN in the data center. Now, we only have 30 minutes, so I'm not going to be able to go into a vast amount of technical detail, nor are we going to be able to cover the theory. However, this talk is about our long-term use of EVPN and VxLAN in the data center scenario. And actually, we've been doing it for some time, and we're going to talk to you about what the technology looks like, what our testing and automation looks like, but we're not going to talk to you about how to roll this out, how to plan for capacity, and how to monitor it. Because, as I've said, we only have 30 minutes. So, with me and my team, for those of you who don't know, I head up engineering in the Claranet group, and with me is Sandy Breeze, who looks after architecture, and Dave Overton, who looks after our automation. So I'm going to start with an introduction and tell you how we got here. In 2014, the story starts with aging equipment, specifically the Catalyst 6500 that I'm sure many of you, if you've been in the industry a while, are intimately familiar with. It was the proud workhorse of the data center, doing everything from L2 switching for us to MPLS-PE. But in 2014, it was almost 10-year-old technology, given the hardware spec and the types of supervisors that we used. And we had constant operational problems with it. Headaches with FIB, QoS and VLAN scale, the management plane, IPv6, L2 VPN, spanning tree. Need I say more? Our fiscal year runs July to June. And in our July 2014 budgeting, we'd assumed some linear growth, and the normal trend back then was to assume that bigger was better. So the base assumption we made was, well, let's stay with the Cat6K, and let's just move to something bigger. So we had the supervisor modules, so that's underpinning the performance of the entire chassis, and we thought, let's upgrade the supervisor modules, let's go bigger, and let's make things better. But the problem was that upgrading the supervisor modules needed to give us both stability and features. And the problem with these boxes is you can either have one, or the other, and you get no assurances of both. So we knew that whatever we did, we'd need a wholesale technology change. But we didn't know what we would do. We didn't know how big that would be. Really, to guide us, we had to look at the driving forces in the data center. So we could see that our customers were piling their infrastructure into virtualization and cloud technologies. And these were the very same people asking us for innovation in the network to cope with the infrastructures that they were building, that they were delivering on these virtualized, hybrid virtualized platforms. So we did quite a bit of research, and we had to look at a number of factors. We needed to see, what features the customers needed, what it would take to do something new like this, what opportunities this would give us, and what principles we'd build it under. How would we implement it? How would we monitor it? How would we automate it? And what about our tooling and documentation? Lots of things that we had to think about. So I'm going to bring Sandy in with the 100 meg card with RJ21 connectors, banana for scale.
Yeah, thanks, Dave. Hi, I'm Sandy. So, as Dave said, it started early 2015 with what was, quite a simple kit refresh project. Turned into something that took over all of our lives for the last 4 years. The goals of it were really simple. We needed to do something with the hardware. At the time, this RJ21 card, those old enough to remember it, was end of everything in 2013. So that's not just end of hardware, support and attach and everything else. you actually couldn't get anything on these. So, we had to replace all of those. Operationally, that was getting really hard to support and expensive. So the network at the time looked like this, probably familiar to most of you. Bunch of 6500s at the top, doing layer 2, layer 3 PE router type stuff, so MPLS and Internet PE. We took a step back from this and said, well, actually, maybe it's not such a good idea to have all of our internet and all of our customer routing for the whole data center on just a handful of devices. The other thing we encountered was any sniff of a DDoS with like high PPS, these routers would fall over because they would lose some BPDUs and then you're in a world of pain. The red crosses on the picture there, spanning tree blocked an instance on a port, so we're not getting good utilization of the links. You can get a bit creative with the route placement, but it was really inflexible. A few years previous, we'd had our virtual data center offering, which is like Claranet's public cloud. Basically, we'd have a portal where people can come and buy CPU, RAM, and network resources. So, anybody with a credit card could come along and buy some VLANs off us. We had restrictions, but even so, we could still see the limit was in sight. I think it's pretty well recognized that, a 12-bit VLAN header just isn't enough to guarantee uniqueness in the data center. And of course, our customers' apps had evolved too, so they needed access to higher bandwidth ports. So yeah, back in February 2015, we approached 5 or 6 network vendors in the data center switching space and said, look, here's all of our problems, what do you recommend? Now, I think they all touted VxLAN in some form or another. The implementations varied quite wildly, though. Some of them were controller-based, some of them were all static VTEPs with flood and learn, obviously some multicast, and then finally we saw a BGP implementation. Now, the BGP implementation was from Cisco, but it was actually from a spin-in that they did a few years before, which was from InCME. When we saw this box, we was actually really surprised at how different it was and how far it had come, how good it was compared to other people on the market. Particularly because under the hood, it looked exactly the same as other vendors' boxes. It was a Broadcom Trident T2. They had a little bit of their own merchant silicon in there, but it was vendor silicon in there, but it was literally all Broadcom merchant silicon. So then we had to ask ourselves whether we thought it was the right time to VxLAN or not. This pretty new technology back in 2015. We had to do a lot of testing. And I wouldn't say we swallowed the Kool-Aid, but, we did it. One of the things that made this really attractive was because the BGP implementation meant that it was going to be a standards-based solution. And to us, the standards is really quite important. So I just want to take a quick look at where they were at the time. So the top one, if you can read it, is 7348. This is the definition of VxLAN. Interestingly, that's not actually in standards track at all. That's an informational RFC, but that was over the line in 2014. Then we've got 7432, which just been standardized the time that we were looking at it. Now, this has nothing to do with VxLAN, really, but it's BGP EVPN. So even though it has an MPLS forwarding plane, it's still quite important, the language and the behavior in there. And then we've got 8365, which Bess had actually only just adopted this when we started looking at it. That's how to do EVPN for overlay networks. And then the bottom one is our DCI overlay, which still isn't standardized, but this is about how to stitch networks together between forwarding and in a overlay network and in an MPLS network.
Just for reference, our implementation is based on BES overlays, so that's VxLAN data plane with an EVPN control plane.
So this is a really high level of what it looks like today. It's by no means a finished product back then. There's a lot of hard work and engineering, vendor bashing, interoping, bugs, modeling, automating, and that still goes on today. But simply it's a leaf spine model. Everything in the middle is a layer 3 point-to-point link. Just run a really simple IGP there. Our customer's layer 3 sits at the top of rack, so on the leaf, so that's nicely distributed everywhere they have their bridge. We don't have any HSRP. We run an Anycast gateway, so there's actually more gateways for the customer, more resilience. All the connectivity, all the data plane learning from the CE to the leaf is then passed into a BGP update message, so there's actually very little flood and learn that goes on in the network. And yeah, I think half of the battle for us in getting to this place where we were today is building up the relationships with the vendor. So we were doing this thing quite early on in their release of the software, and we built up a really good relationship with Insieme. So we gave them loads of feature requests, and a lot of those features have made it into production. Those of you who are familiar with the Nexus 9300 probably saying, well, why didn't you just do ACI? Well, we looked internally and saw that we had a networks automation team, which had come through acquisition, but basically they've been writing network code for the last 12 years. So we thought, well, let's do what they do and use them. One of the advantages to doing it ourselves, of course, in this standalone NX-OS model, is that it kind of keeps the vendor on track with standards-based and interop, because there's nothing like smoke and mirrors to obscure some of that. We felt really good about what we'd built because it was not using any kind of third-party software. We built it all ourselves. But I guess the important thing is that we couldn't have done it without automation. And yeah, that's where we are today. Dave's going to tell us about that.
The Dave slide. Let's go to the...
Oh yeah, so as Sandy mentioned, we have quite a bit of history of automation at Claranet. Given the opportunity to develop this in parallel with the platform with no customers on it was a really good opportunity for us. Looking at the config of these Nexus switches, they definitely needed automation. The VxLAN and EVPN configuration is significantly larger and more complicated than the traditional layer 2 iOS and SVIs. This prevents lots of opportunities for engineers to make mistakes, especially when you factor in Anycast gateway, which you might have to go to multiple switches to configure similar configuration. There's also a risk that the additional power and flexibility of these devices might let engineers make up non-standard and difficult to support solutions for customers. We don't want people to waste their time doing this sort of thing, and we don't want them to waste their time pasting configuration onto devices. We do automation though. Our existing system already overlapped with Golf quite a bit. Our Ethernet platform is fully automated, which means that people don't ever touch a network device in order to configure the services. And some, but not all of our data centers are automated up to layer 2, which means that switch port allocation and VLAN trunking is done by the system, but they would still have to SSH on to 6500s to configure the layer 3 aspects of things.
Excellent.
Yeah. So our automation stack, it's built entirely in-house. Parts of it, as Sandy said, are getting on for 12 years old. It's very well maintained, I would add. At its heart, it's an abstract model of our network services. It's the authority for many of our networking elements, including IP addresses, VRFs, VLANs, switch ports, anything you can think of like that. Users make changes to the network using a web-based front end. Changes are monitored, processed and synchronized devices on demand using components that we call policers. Typically there's a police for each network vendor or API that we have on the network. The system also exposes a REST API, which is used by other systems in order to make changes to the network. It's what the rest of the business likes to call network automation. Next. So where do we start? Well, We start at the beginning, provisioning the devices themselves. We don't ever want to touch these devices. Want it to be completely hands-off. Nexus offers a system called POPE, which is power on auto provisioning. In order for this to work, the system needs to have prior knowledge of the device that we want to provision. In order to put this information in, we've got a command line tool called gulfconfig. This tool is responsible for doing the spine switch port allocation, IP allocation, and so on. In order to add a switch to the system, a person only needs to know the location, serial number, and model of the device. Just briefly, POPE works by the switch booting up on an out-of-band management network, downloading the latest NX-OS, booting that up, then downloading the configuration, base configuration, which is served up directly from our REST API via template translation from our internal model to the Nexus config. This brings up very, very basic static configuration, stuff that we don't ever intend to change, and just enough to get the switch available on the front end. Once that's done, the police then connects in, finishes off the configuration, does things like BGP, anything dynamic, and then it's all ready to go. Speaking of which, how does the policer talk to the device? Well, Nexus switches provide a REST API called NX API. Problem solved? Well, not exactly. While NX API can produce an XML configuration, the document structure is convoluted and awkward to work with. The API endpoint can't be secured. It's possible to put it into a VRF, but this isn't ideal for our purposes. And worse of all, changing the configuration requires sending XML encapsulated CLI commands. This doesn't really offer any compelling advantages over using the CLI. So what else can we use? Well, in the version of Nexus that we first started working with, which is quite some time ago, we stumbled across what's now called the NX API REST for MDP, that's model-driven programmability. We believe it was the API used by ACI at the time. Unfortunately, when we looked at it, it didn't model VxLAN at all, so it wasn't really viable. That's now evolved into the aforementioned title. It's a proprietary model, but everything's there, and if we were doing it today, it would be a viable way of doing it. At the time, we ultimately decided that it was a no-go for us, so we enhanced our existing code. Our CLI system already had support for Nexus in the form of Nexus 5000s, which we had deployed in the data center, and it also had some knowledge of basic layer 3 configuration, where it had previously been responsible for part of our Ethernet AG platform. So we enhanced this code. Just briefly, we had to rewrite the parser. It wasn't the best. It did work, but we had to teach it about all the shiny new features, taught it about VxLAN, EVPN, L2VNIs, and then finally modified the existing layer 3 code to understand Anycast gateway. So we still scrape the config. We still work with the CLI. It works very well, surprisingly well. It's much faster than a traditional IOS device. And best of all, it doesn't have to be this way forever. So, okay.
Right, so we've built this stuff. We now need to get people off the legacy and onto the new for a number of reasons. Well, one of them being because we wanted to give that old stuff back. It was used as trade-in, so we needed to get off it. There's lots of ways you can do migrations, and we sat down and toyed with quite a few of them, but we knew that our migrations were probably going to take quite a long time. I mean, in our first data center, the volume of customer ports that we needed to move was about 5,000 customer ports. So whatever method we used needs to be pretty robust, and it's probably going to stay there for a little while. We chose to do this interconnect method, where we basically run in a topology that's interconnected with the old, and we would split out the layer 2 and the layer 3 responsibilities between the old and the new platforms. We knew that the old one was pretty fragile when it came to things like spanning tree, so I've put backup interface on there. This is basically because we didn't want to run spanning tree with the old and steal everything into the new, because it would fall over. So this backup interface thing is what I think Cisco called FlexLink. It's basically poor man's spanning tree. So if one port is up, then the other one is down. And if that changes, then so do the port statuses. So then after we interconnected them, did all the layer 2, we then moved all of the layer 3 off the 6500s and up to the top of racks on the interconnect switches. And then the second phase of the migrations would be to actually go and shift all of the customer ports. There's a few advantages that we had to doing it this way. Firstly, I mentioned the clear divide between layer 2 and layer 3, so it's operationally easier to troubleshoot and support. Secondly, we've got a common platform that our provisioning systems can deploy to, so we're not holding up any business operations by, doing it this way. And lastly, most importantly to us, with the right tooling, those physical shifts can be done with pretty much any team in the business. And yeah, talking of those tools that we use for migrations.
So as with the rest of the automation, for migrations we also enhanced a tool we previously used. This tool was originally written for the migration of an Ethernet platform from Cisco 7600 to ASR 9K. This meant it already understood a lot of the things it was going to encounter on a 6500, such as VLANs, SVIs, BGP, and so on. This works through static analysis of the configuration files. Effectively, once we taught it how to follow links to other devices, it takes in the first one, or it sucks in, which is why we call it ILSUCK, reads the configuration, tries to reconcile that with a service model, a known service model that our system can deploy. Once it's done that, it then injects those data structures into the model in the database. Importantly, in order to write this configuration out to the new devices, it's done through the same deployment mechanism as the normal provision. There's no specialist code for writes, it's only on the read side.
Right, well, there had to be a slide about it, really, didn't there? It wasn't all plain sailing. We were dealing with what was then new technology. Some of our pain points come down to just implementations, things that the software did that we, kind of wish that they didn't. Things like reserve VLANs. So yeah, we, out of the box picked up this thing and it had, 128 VLANs just carved out of it. Some of those, we wanted to use those VLANs. So then we thought, well, maybe we can just map them because it has this concept of like per port VLAN mapping. But no, the reserve ranges, you can't even map out of them to get you out of trouble. L3 VNIs, those familiar with the concept, they also burn VLANs, which, again, reduces your scale. Some features just don't work. And, you phone up and say, hi, there's this topology. It takes you a good hour or so to explain your topology for then, somebody not to sort of understand it. Reflecting on this, I think we could just say, well, it's new to everybody, and it's a learning curve for everybody. Not everything had filtered down. Our saving grace was that actually we had this relationship with the business unit, and most of our cases were escalated into the business unit pretty quickly. And I'm pleased to say that, they weren't actually config issues, so the TAC couldn't have dealt with them anyway. Yeah, as with anything, testing reveals something that isn't in the documents. I think if you didn't have the mentality of nothing works until you've seen it working, before you start on a project like this, adopt that mentality. Even simple things like, yeah, of course a layer 3 ACL on an SVI works like this. No, it doesn't, not unless you've seen it working. Expect new, undocumented behavior, even in the same features train. That happens frequently. Get used to living in that world. You can't just turn features on and off. You have to have a good test plan. Get yourself a lab, and automate the lab as well. Be able to run the lab, run your test plan on demand in the lab, as much as you want to just think that this will solve all of our problems and do another feature. You can't risk it, not with new technology. I briefly mentioned this earlier. I want to come back to it though. So Cisco launched on the Nexus 9300 with the T2 and a bit of their own silicon, but it was the T2 chip that was doing all of the clever VxLAN stuff. So yeah, we went with that. We got all of the features. It's really good. However, we hit problems with the Broadcom. Scale problems. The TCAM, again, bane of our life. We just come from a 6500 world where TCAM's one of the big problems, to go and invest loads of money on new stuff, and there's, again, TCAM problems. Race conditions, so, programming the hardware. Sometimes we would get RIB and FIB inconsistencies. And then there's second generation of switches, which I think they called the Sugar Bowl ASIC. That's
their own chip.
Their own chip, and that completely switched out the Broadcom. For us, maybe because, the code had, just got better, I don't know, but it was a lot more stable for us on that. But it wasn't all, lights and fireworks. They missed a load of features that only the Broadcom was doing and wasn't doing a new chip. So, now we had software and hardware feature parities to worry about, along with everything else. So yeah, in summary, I'd say you know what you're getting yourself in for. The config's hard. There's a lot of scope for human error, so you need some tooling. You need to understand your customer's layer 2 networks and what they do. I mean, VxLAN doesn't have a problem forwarding any packet, but your vendor might have made some decisions for you about whether they're right to forward packets. Things like BPDUs, LAC PDUs, not by default. Understand the new behaviors that you might be seeing. Things like MAC moves is used to detect loops. How many MAC moves should you tolerate? What should you do if you see this threshold being broken? Do you freeze it in L2 fib? Do you shut down the ports? But I'd say importantly, get a lab, get a good test plan, run the test plans all the time, and keep it relevant.
And I'd just like to conclude this by saying EVPN's a thing. It's not even a new thing. I mean, almost all vendors now in the data center space have got some kind of shipping EVPN implementation. We've been doing it for years. Title of the presentation says 3, but if I think about it, we've probably been working with it for longer. It's stable, and we're offering production services with service level agreements on it. It's best served with automation. Not necessary, but it really has a massive impact on the experience that you have when you can automate it with whatever means. So we've got a minute or two for any questions if anybody wants to ask. I see a hand over there.
Hi there, Pete from Cumulus Networks. I'm curious, any lessons learned on safety checks around automation? You talked about a web interface for your network engineers. Anything you can share with what you've done to make sure that nobody mangles the network in mass scale?
We've got a few checks, things like the size of the configuration file not changing. We've got checks, mostly regular expression based around, how many things are being removed on a particular run, things like that. Anything trips those thresholds, it stops and it won't do anything.
Yeah, it's generally deltas and beacon config points and important.
Maybe mention how we debug devices.
Oh yes, and sorry, I'm shouting to the mic. And yes, of course, if we hit any of the exceptions in the runtime testing, the devices drop out of the automation, and they can only be put back in with operator intervention. So they get no automated changes to them after that. Any other questions? No? Okay, well, just last slide. And if this sort of stuff interests you, we're currently hiring, so come talk to me later. Thank you.
Okay, thank you all.